Students, in previous part we have discussed first 5 laws of exponent. Now in this video we will discuss the remaining 4 laws of exponent. Let's start with zero exponent. This law states that a non-zero base raised to a zero exponent is equals to 1. Means there is a condition that this base should not be 0. It can be negative or positive. Here, if a equals to 2, then 2 raised to the power 0 is 1. If the base is 100, then 100 raised to the power 0 is 1. Means any number with power 0 is always 1. Next law is identity exponent. And this law states that any number to the first power is itself. And itself is exactly the base, right? Now, if the base is 4, then 4 raised to the power 1 is again 4, right? If the base is 100, means 100 raised to the power 1 is 100, right? This is the identity exponent. Next, we have negative exponent. This law states that a negative exponent means take the reciprocal. Here you have an exponent with negative power. You have a quantity with negative exponent, and to make it positive, what you have to do? You have to take reciprocal of it. Then in numerator you will get 1 upon a raised to the power n. Now it becomes positive, right? And if you have a number or if you have a quantity which has negative exponent in denominator, then again you can flip this and it will become a raised to the power positive n, right? Let's understand with example. Here you have 2 raised to the power minus 3. To make it positive, what you have to do? You have to flip it 1 upon 2 cube, right? Or for this, again, if we have 1 upon 2 raised to the power minus 3, then we want to make it positive, then we will flip it as it was in denominator. Now it becomes a numerator and it becomes positive as well, right? If we have a fraction, if we have a rational expression with negative exponent, then what you have to do? In this case, you have to flip the base, right? As you can see here we have x upon y raised to the power minus n. While we convert it as a positive power, then what you have to do? You have to flip this x upon y as y upon x. Now the power becomes positive, right? Now let's see the example. Here 2 upon 3 with power minus 2. If we flip this expression, rational expression, then it will become 3 upon 2 and the power will become positive, right? Next we have fractional exponent. Suppose you have a fractional exponent a raised to the power 1 upon n. This will be equals to nth root of the base. You will discuss root in your upcoming lecture. Now for this time you have to just think about it, that whenever you have a power in fraction, then you have to take the nth power of that base, right? Here, as you can see, we have a equals to 8 and n equals to 3. Then 8 with rational or fractional power 1 upon 3, this will be equals to third root of 8, right? Now let's understand and let's solve some question related to laws of exponent. Write each of the following expression without exponent. Here we have first part 0.2 raised to the power 5. As we have to write it without exponent, means just you have to identify what is base and what is exponent here. As base is 0.2, means base is going to multiply how many times? 5 times, right? Now just you have to write 0.2 multiply by 0.2, multiply by 0.2, multiply by 0.2, multiply by 0.2, right? Now, in next question, we have a rational expression 1 upon 3 with power 4. Now, we have to expand this base how many times? 4 times. You can multiply it 1 upon 3 times, 1 upon 3 times, 1 upon 3 times 1 upon 3, right? This is your answer. We are not going to simplify it. Now, here in this third part, we have to solve it. As you can see, there is 3 getting multiplied with this minus 4 raised to the power 2. Means we have to expand this part only. Minus 4 will be expanded 2 times. Here 3 as it is, minus 4 times minus 4. Student, it is important to note that all the dots, multiplication, and only 2 brackets are denoting the product, right? Means if you are going to observe some dot in between 2 quantities, that means you have to take the product here, right? Next, we have another question. Write each of the following expression in single exponent form. We are not going to solve any question, just write in single exponent form. Now, here first question is m dot m dot m, means we have to take product. As you can see, all the bases are same. Power will be added. First law, product law, right? M cube is the answer. Now, second, we have a square b cube with whole raised to the power 4. Here you can see we have 2 bases within the parentheses with the power. Okay, first what you have to do, you have to just distribute this power to both the bases like this. Okay, then again here you will apply another law, which is power of a power law. If you have a base with power and again raised to the power, what you have to do, you have to multiply the powers, right? Here you can see a as it is 2 multiplied by 4. For b as it is 3 times 4, right? Now a equals to 2 times 4 is 8, and b with power 12, right? This is your answer. Now in third part, we have a fractional expression with negative sign. Here you have to write it only single exponent form. Then what you have to do, you have to just multiply power with power, right? Now here you can see minus m upon n 2 times 5. We have taken the product of the powers, and this will be equals to minus m upon n raised to the power 10, right? Now students, we have to simplify the following. First question, 16 times a raised to the power 8, b raised to the power 12, and in denominator we have 8, a raised to the power 3, and b raised to the power 6. Now let's start solution. Here you can see we have 2 like bases, but whenever we have 2 bases in division form, then we will use which law? We are going to use second law, quotient law. What you have to do? You have to write base ones and subtract the exponent, 8 minus 3, right? And then again we will use the same law. We will subtract the exponent, and in denominator we have just 8. 8 ones are 8, 8 twos are 16. After simplification, 8 minus 3 is 5, and b with 12 minus 6 is 6, right? Now in second part, in second question, what you have to do, you can see we have 2 signs are here, 2 negative signs, first in numerator and second one is in denominator. And you can see 2 minus p minus 3q with power 12 raised to the power 12, and in denominator we have the same base, right? Then again we will use the same property, and minus 20 times 2p minus 3q. Now 12 minus 9, subtract the exponent, right? And here 4 minus 3 times r with power 3, and here in denominator we have 4 minus 3 r with power 1. You can see there is no power here. We will consider it as 1, right? Now 4 minus 3 times r with, what we have to do, you have to subtract the exponent, 3 minus 1, right? Minus minus become plus, 4 5s are 20. Now 5 here. 2p minus 3q with power 12 minus 9 is 3 and 4 minus 3r with power 3 minus 1 equals to 2. This is the answer. Hope you all understand today's lecture. Now be prepared for little assignment and quiz. Till then, best of luck.